Hello class, it's Mr. Calvin here again, and today we will be looking at what are called collecting like terms. And just to relate this back to the previous lesson, you were actually introduced to what a term is. So remember what a term is a combination of a coefficient or a number and a variable or a letter grouped together. Now what we're going to see is what happens when we have what are called like terms and unlike terms, and how we can when to know when to put letters together and when to leave them apart. So that's what we're going to focus on in today's lesson. So when we're looking at collecting like terms, what you just have to understand is that anytime you see a letter, you have to ask yourself whether the letter and whatever is around it is what is called like or unlike. And what we're going to do here again is to get a better understanding of what those like and unlike terms are. So starting off with what like terms are is that like terms have identical variables or the same variables. Now, this is where it gets a little bit tricky because sometimes variables have exponents attached to it. Now, when we're dealing with uh, like terms and we're dealing with variables or letters, we have to consider the fact that when you look at a letter, you also have to look at the exponent that's attached to that letter. So in the event that you take a look at a letter and the letter happens to have other, let's say the letter X, if you have a bunch of X's and they don't have the same exponent, then they would be considered unlike terms. Now, once you have what are called like terms, which are the same variables with the same degree of the same degree of the exponent, okay, then you can actually group them together either by adding or subtracting. So the first thing we want to do just to warm ourselves up is what it means to identify what are called like terms. So let's start off with an easier one here. We have 5x, 8, negative 3x, and negative 7. Now remember what a like term is when you have a variable, okay, and it happens to have another, you have the same variable that also has the same exponent. Okay, so starting off with the first one here, if you take a look at the 5x and you look at the remaining three terms that you see there, okay, the only like term there will be the negative 3x. Now you're probably wondering, well, what about the 5 and the negative 3 that's in front of the x? Okay, remember that those are coefficients. When we're looking at the terms, we're simply just looking at the variables. And in this case here, notice that both the x's, okay, both have the exponent or a degree of 1. So we can group those two together. Now you're probably wondering, well, what about the 8 and the negative 7? Now, anytime that you have numbers by themselves, okay, those would be considered like terms because you can add or subtract any sets of numbers. So the 8 and the negative 7 would both be like terms simply just because they're both numbers. All right. Now this is where you need to be careful because notice for part B, okay, we have 4x squared, negative 7x, 2, negative 10, negative 3x squared, and an x. So notice that we have different different x's here for this particular question. Now, even though that we have a bunch of x's, we only group the x's that have the same exponent or same degree. So if you take a look at the 4x squared, okay, and you look at the remaining terms there, the only like term there for 4x squared here is the negative 3x squared, because the other x's that you see in this problem here, specifically just the negative 7x and the x, okay, those do not have the same exponent. Okay, now the negative 7x, okay, and the x, those ones are like terms because they both have an exponent of 1 attached to the letter x. Okay, so I have these in colors just to show you again so you can see the difference between the two x's that we have in this question. And last but not least here, since the 2 and the negative 10 are both numbers, those would be considered like terms. So again, even though we have a bunch of x's, we're only grouping together the x's that have the same exponent. Okay, so for this one over here, we have 6a squared, negative 12ab, 0.5a squared b, negative 3a squared, 4ab, we have a negative 1, and a 7b squared. So we have a lot of stuff going on there. Now remember that when you're looking at like terms, you're looking for something that has the exact same letter with the exact same exponent. Now, the same applies if you have terms that have two different letters attached to it. So specifically notice that we have a negative 12ab there. So anytime you're looking at collecting like terms, you're only grouping the terms that have the same variables with the same exponents, and that also includes different variables, okay? So starting off with 6a squared over here, if you scan through, there's only one term that has an a squared, so that's going to be negative 3a squared. Now you're probably looking at that 0.5a squared b there and thinking, well, why can't we include that? Well, 0.5a squared b, well, it has a b attached to it. So even though there's an a squared, okay, the fact that there's also a b attached to that, then makes that particular one an unlike term compared to the ones I've boxed there. All right. So next thing that I have here, we have negative 12ab. So if you scan through here, the only term that also has ab and just ab is going to be 4ab. Okay. Now again, going back to 0.5 a squared b, you know, why is that not part of this? Because for this one though, even though it has a and b, okay, you notice that the a has a squared attached to it. So that part there is an unlike term to the negative 12ab and the 4ab. So you're probably wondering, well, how about the remaining three terms? Well, all three terms, specifically the 0.5a squared b, the negative 1, and the 7b squared, okay, would be all considered unlike terms. All right, so now that we've learned how to identify like terms, let's now see how we can use the operations when we collect them. And this is what collecting like terms is. Well, what do we do once we've identified what the like terms are? All right, so for the next one over here, we're now going to understand what collecting like terms are. And basically, anytime that you have two variables with the same exponent, you can either add or subtract them depending on the operation that we have. So start off with part A here. We have 5x plus 7x. Now, when you're collecting like terms, all you're simply doing here is you're adding the coefficients together, but the letter remains intact. So just to start us off here, 5x plus 7x, that's just going to give me 12x here. Now you're probably thinking, well, you know, how about the exponents of the variables? How come they don't change? Remember that the only time that the exponents of the variables change is when we use the exponent laws, specifically when we're multiplying the like bases, dividing the like bases, or if we have the power rule. Okay, so when we're collecting like terms, okay, we're just simply adding or subtracting the numbers. Okay, so for the next one here, we have 6x minus 9x. Okay, so a good way to look at this is take a look at the 6 and the 6 and minus 9 together. So 6 minus 9 is negative 3. So what we would have here for 6x minus 9x is negative 3x. All right. Now, just a little bit of reminder for this one here, we have 3x squared minus x squared. So again, anytime that you see a variable and there's no number in front, what's really in front there is an invisible 1. Okay, so what we have there will be 3x squared minus 1x squared, okay, which is going to give me 2x squared. All right, so just gonna make a little note of that example there. Okay, so start off with the first three examples here, simply grouping the terms side by side here. So what happens when we have a combination of, let's say, a letter or a number? Well, for example, what we see in part D over here. So the first thing we're going to do here is we're going to identify and then collect the like terms simply by writing them side by side. So pay very close attention to how this is done. So for part D over here, let's start off with a 7x. So if you scan through the remaining terms there, the only term there with an x is the plus 2x. Now what I'm going to do with those two terms is I'm going to group them side by side simply by putting them, well, side by side. So in the next line, what I have here will be 7x plus 2x. Now notice I did not add any signs other than the sign that's in front of the coefficient. So that's why, again, I just put the 7x and the positive 2x, okay, just group them together there, okay? And same thing with the 5 and the negative 3. So in the next line here, we're going to take this positive 5, okay, and the negative 3, which then becomes plus 5 minus 3, okay? So that's step number 1. And the last step here, we're going to group the like terms together. So for example, 7x plus 2x will give me 9x, and then 5 minus 3, that's going to give me 2. Now, this is the final answer to this. And the reason why I'm mentioning that is because you cannot group the 9x and the plus 2 together. Okay, because notice that the 2 doesn't have an x, so you cannot group those two together there. Okay. Okay, so for part E, it's identical to part D over here. So start off with 6x. So for this one over here, you need to find the like term that also has an x. Okay. Now, when you're identifying the like terms, you also need to include a negative. If there's a negative that's in front of the number. So the like term to 6x here in this case here will be negative 3x. So when I group those two together, what I wind up getting here will be 6x minus 3x. Because remember, once you group the terms together, the negative then becomes an operator, which in this case here is subtraction. Okay, so the next like terms here is negative 2, okay, and positive 9, which we bring down to become minus 2 plus 9. Now for the final step here, again, you're only going to simplify the like terms. So starting off with 6x minus 3x, that gives me 3x, and then negative 2 plus 9, that's going to give me plus 7. So the final answer for this will be 3x plus 7. All right, so again, if you take a look at the questions over here, that anytime you're looking at the like terms, you're only looking at the letters with the same exponents. And in the case of numbers on their own, you group them because they're simply just numbers. All numbers that are on its own are always like terms. All right, so more examples here. And for this next one here, just threw in a different letter here as well. So we have negative 3x plus 10y minus 2x minus 8y here. So starting off with the negative 3x, if you scan through here, the only term with an x here happens to be the negative 2x. Okay, and again, what we have there, we're going to group those two together. Now again, just as a reminder, and I mentioned this in class as well, is that when you're dealing with communicating your form, you always start off, you always write down your solutions from the top to the bottom, and you start each line there with one equal sign. And don't forget, there's only one equal sign per line here. Okay, so again, if you scan through the examples, you'll see that I've done every example the exact same manner. Okay, so that's those are dealing with x. Okay, so for the next part here, we're going to look at the positive 10y, and the like term for that is negative 8y. But when we bring it down, they become operators, and that'll be plus 10y minus 8y. Now, all we're going to do here is we're going to group the x's together. So negative 3x minus 2x gives me a negative 5x, and then 10y minus 8y gives me plus 2y. Again, notice that since the x and y's are unlike terms, you never group them together. All right, this next one over here, we now have negative 4x squared plus 12x minus 3 plus 6x squared plus 2x minus 5. Now, focusing on the x's, okay, even though we have 4 sets of x's there, we're only grouping the ones that have the same exponents with each other. So starting off with the negative 4x squared, you want to find a term that also has an x squared. So in this case here, what we have here is 6x squared. So I'm going to bring those two together as negative 4x squared plus 6x squared there. All right, now this 12x, which I'm going to box in blue, this is now an unlike term compared to the x squared, because this x here has an exponent of 1. So the only term there that has an x, that's going to be the 2x here. So I'm going to group those two together. And again, you always group numbers together. So we have negative 3 and negative 5, which comes minus 3 minus 5. Now, for the last step, you're only going to group the terms with the same variables with the same exponents. So what we have here is negative 4x squared plus 6x squared, which gives me 2x squared. 12x plus 2x, which gives me 14x, sorry. And then negative 3 minus 5 will give me negative 8 or minus 8. Now again, just as a reminder, this is the final answer to this. You cannot group the x squared and the x together because they are unlike terms, and you can't group the negative 8 with either of them because again, it's an unlike term. Okay, so what you have there are 3 different terms. All right, so that wraps up collecting like terms. So continue working on the workbook or the textbook questions if you have it, and see you in the next lesson.